Well, what are these type 1 and type 2 errors? Again, remember, we're making conclusions, right, from the sample data. And one of the conclusions would be that we reject the null hypothesis. Another one would be we do not reject or fail to reject. So in here we see a type 1 occurs when our data lead us to reject the null hypothesis. We say, you know what? The null hypothesis is not true. Like in this case, you are negative. You don't have COVID. But in reality, the null hypothesis was actually correct. And so we made a mistake when we said you are negative, right? I'm sorry, we reject that you're negative, but you actually are positive, right? That's our conclusion. But in reality, the null hypothesis was correct. You're actually negative. That's like what we call a false positive in this case. That would be a type 1 error. That is that the test finds that you are positive because we rejected the null. But in reality, in the real world, you're not positive. You were negative. So the test was bad. Um, and when we make that conclusion, that's a false positive. That's what a type 1 error is called, when you reject the null hypothesis. However, you are positive, or we say you're positive, but you're actually negative, a false positive. Type 2 error, considering that same scenario, is when our data, the sample data, lead us to say, do not reject the null hypothesis, but in reality, the null hypothesis is incorrect. The alternative is true. So we say you are negative. The test finds us negative, but in reality, you do have COVID. You're positive, a false negative. Now, something to think about in this real world context: which type of error is worse? Do you want to have a type 1 false positive or false negative? And the answer to that question is contextual, meaning that it depends on the circumstances of what we're testing. What's worse? Would you rather have COVID and not know it, or would you rather, what's worse, right? Having COVID, not knowing it, or not having it and someone saying you have it? What's worse? Again, that's all contextual. It's something to think about. We summarize type 1 and type 2 errors using this table here. It's exactly what I said here. It's just put in a table. You reject the null hypothesis. It's a type 1 when you reject it, when the null hypothesis is actually true. When you reject the null hypothesis and the alternative is true, then that's a correct decision. So keep that in mind. If you do not reject the null hypothesis, do not reject it, but the alternative is true, that's a type 2 error. So make a note of that and think about again. It takes a little bit of time to kind of think about that scenario as we go through that. Now, this is just, again, a practice writing interpretation for this. Imagine we're testing the average of light bulbs, how long light bulbs are, measuring the life in hours using the hypothesis the mean is 1,000, and then we have some idea that maybe it's less than 1,000. A type 1 error would be us saying to write a false positive, right? To reject the null hypothesis. The sample data suggests that the mean life for light bulbs is less than 1,000, so we reject the null hypothesis, when in reality the mean life is 1,000 or more. That would be a type 1. A type 2 is the error if we do not reject, meaning that the sample data shows that the mean life for light bulbs is 1,000, but when in reality it's actually less than. Again, it's not us making the error, it's us making a conclusion off of the sample data, and due to the variation, we could have these types of errors. We talked about consequences. I said that was that question, what's worse, right? These are the different things for that COVID example. Type 1 error, right? Saying that in that COVID example here, a type 1 error, right, is saying the test says you're positive, but you're really negative. So what happens is that you miss work, you lose money. So that's something, miss a family gathering. Or type 2 error, if you make that, then what could happen is people think they don't have it, so they spread the virus, don't get medical help. So it's important to keep that in mind. And lastly, how can we control for the chances of making an error? Well, there are two main ways of controlling for risks of errors, but again, there's a give and take between the types of errors. One is the level of significance, because remember, we use a probability value to determine whether to reject or don't reject. Another way is to increase sample size, so to ensure that the data is accurate, right? A larger sample size. If you change the level of significance in terms of this, increasing the risk of type 1 error. If you increase alpha, you decrease the risk of type 2. So it goes hand in hand. So you have to decide which one's more important to you. If you decrease the alpha, make the alpha smaller, then you decrease the risk of a type 1 error. Maybe that's more important. And increase the risk of a type 2, right? So it's hand in hand. Okay, there's a potential error. If you decrease one, you increase the other. And the sample size, decrease the risk of a type 2 error, but does not affect the risk of a type 1. So keep that in mind.